Good day everyone. Let's try to answer some math problem posted on Facebook. And special credits to Master Lerby at Roof for sharing this wonderful question. And I hope I pronounce your name correctly. So let's start. Here's the question. Let f of x equals x raised to the fourth power plus ax cubed plus bx squared plus cx plus d, wherein a, b, c, and d are real numbers. Suppose that the graph f of x intersects the graph of y equals 2x minus 1 at x equals 1, 2, and 3. Now the question is, find the value of f of 0 plus f of 4. Now if you want to try this problem, just pause this video, and if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. I will provide two solutions in this question. The first one is quite long, and the second one is what we call a shortcut. Without further ado, let's start with our first solution. So first thing to do is to let f of x be equal to y. So we have y equals x to the fourth power plus ax cubed plus bx squared plus cx plus d. Now we know that this quartic equation intersects at this equation y equals 2x minus 1. It follows that they have the same y value. Therefore, we can replace this y by 2x minus 1. So we have 2x minus 1 equals x raised to the fourth power plus ax cubed plus bx squared plus cx plus d. Next, what will happen if we let x equals 1? If we do that, we get that 1 equals 1 plus a plus b plus c plus d. We get this result if we let all x be equal to 1. Now what will happen if we let x equals 2 or all x be equal to 2? We have 3 equals 16, 2 raised to the fourth power is 16, plus 8a plus 4b plus 2c plus d. And the last one, what will happen if we let x equals 3? So we have 5 equals 81 plus 27a plus 9b plus 3c plus d. Yikes! We have 4 unknowns in just 3 equations. But again, don't forget our goal. Our goal is to find the value of f of 0. So let x be equal to 0. Now at this point, we will use the first equation. We know that y is just f of x. Therefore, f of 0 is simply equal to d, because if all x here is equal to 0, x raised to the fourth is 0, ax cubed is 0, bx squared is 0, and cx is also 0. So we will have f of 0 equals d. Next, we also want the value of f of 4. So let x be equal to 4. So we have f of 4 equals 256 or x raised to the fourth power plus 64a, because 4 raised to 3 is equal to 64. So 64a plus 16b plus 4c plus d. And again, we want the value of f of 0 plus f of 4. So we have 256 plus 64a plus 16b plus 4c plus 2d. We have d plus d, so we have 2d. Now our goal is to evaluate this expression. To do that, we need to simplify this first equation. So we have 1 equals 1 plus a plus b plus c plus d, and subtract 1 both sides, and we have 0 equals a plus b plus c plus d. Next, on the second equation, subtract 16 both sides, and we have negative 13 equals 8a plus 4b plus 2c plus d. And on the third equation, subtract 81 both sides, and we have negative 76 equals 27a plus 9b plus 3c plus d. Now, using these three equations, our goal is to evaluate f of 0 plus f of 4. So let's do that. Now, using these three equations, first thing to do is to subtract the first equation to the second equation. If we do that, we get negative 13 equals 7a plus 3b plus c, and we can cancel out d. So 8a minus a will give us 7a, 4b minus b will give us 3b, and 2c minus c will give us c. Next, subtract the first equation to the third equation. If we do that, we get negative 76 equals 26a plus 8b plus 2c. Next, get this equation, negative 76 equals 27a plus 9b plus 3c plus d. And subtract 3 times the equation, negative 13 equals 7a plus 3b plus c. Surprisingly, if we do that, we get negative 37 equals 6a, because 27 minus 21a, we have 6a. We can cancel out 9b and 3c. And we have negative 37 equals 6a plus d. Now at this point, I will tell you that we can now evaluate this expression f of 0 plus f of 4 using these two equations. 26a plus 8b plus 2c equals negative 76, and 6a plus d equals negative 37. Now the question is, how? So first thing to do is to separate 64a by 52a and 12a. 52a plus 12a is the same thing as 64a. Bring down 16b, bring down 4c, bring down 2d, and bring down 256. Next, factor out 2, and we have 256 plus 2 times 26a plus 8b plus 2c. Now, this is familiar to us because it is equal to negative 76. Next, plus 2 times 6a plus d. And 6a plus d is again familiar to us because it is equal to negative 37. Now, substitute all those values and we get 256 plus 2 times negative 76 plus 2 times negative 37. Simplify and we get the value of 30. Therefore, f of 0 plus f of 4 is simply 30. And we're done. Now, this is the long method. Now, how about the shortcut? So, let's see. First thing to do is to think of a function that satisfies this condition. It is a quadratic equation and it satisfies y equals 2x minus 1 at x equals 1, 2, and 3. So, let f of x be equal to x minus n multiplied by x minus 1 multiplied by x minus 2 multiplied by x minus 3 plus 2x minus 1. Now, the question is, how do we come up with this function? Now, notice that we want a quadratic equation. That's why we have 4 factors of x. We have x minus n, x minus 1, x minus 2, and x minus 3. Now, the next question is, why we have x minus 1, x minus 2, and x minus 3? Now, notice that if we let x equals 1, this term becomes 0. The reason is, it has a factor of x minus 1. If we let x equals 1, 1 minus 1 is simply 0. And 0 times anything is just 0. And what's left is 2x minus 1. And this is just our equation right here. So therefore, it satisfies the second condition. Also, if we let x equals to 2, this term will also cancel out because it is just 0. And again, we satisfy the second condition. As well as if x equals 3, this term becomes 0 because it has a factor of x minus 3. And again, it satisfies the second condition. Therefore, we can let f of x be equal to x minus n multiplied by x minus 1 times x minus 2 times x minus 3 plus 2x minus 1. Now, don't forget our goal. Our goal is to solve for f of 0 plus f of 4. Now, replace all x with 0. So, we have f of 0 equals 0 minus n times 0 minus 1 times 0 minus 2 times 0 minus 3 plus 2 times 0 minus 1. Now, simplify. We have negative n times negative 1 times negative 2 times negative 3, and we have 6n. And then, 2 times 0 is just 0, then bring down negative 1. Therefore, f of 0 is simply 6n minus 1. Now, keep in mind that f of 0 equals 6n minus 1. Next, we also want the value of f of 4. So replace all x by 4. If we do that, we have 4 minus n times 4 minus 1 times 4 minus 2 times 4 minus 3 plus 2 times 4 minus 1. Now we have 4 minus 1 is 3 times 2 times 1. So we have 3 times 2 times 1, we have 6. 6 times 4 minus n, and then plus 2 times 4 is 8 minus 1, we have 7. So we have 6 times 4 minus n plus 7. Now simplify, distribute this 6. We have 6 times 4 is 24. 24 plus 7 is 31. So we have 31 minus 6n. So we have f of 4 equals 31 minus 6n. Now we have the value of f of 4. It is equal to 31 minus 6n. Now don't forget our goal. Our goal is to find the value of f of 0 plus f of 4. Now we have the value for f of 0 and f of 4. It is equal to 6n minus 1 plus 31 minus 6n. Now we can cancel out 6n and negative 6n. Therefore, we have negative 1 plus 31. And negative 1 plus 31 is simply 30. Therefore, f of 0 plus f of 4 is equal to 30. And we're done.